Well, I'm excited to talk about AI today, so we'll get into it. Thank you. So I'm ready to go. So thank you so much for coming today to hear me talk about a lot of ideas that I have. So I definitely want to give time at the end, and I think I have plenty of time to do so, for questions, discussion, ways that anyone else has seen AI work really well for process. That's really the topic for today. I called it double RAG, so I'm going to give you a bit of a disclaimer. RAG, of course, I'll explain what we're talking about here in the talk, but if I was to today come up with this talk again, I would probably call it something different. I'd probably call it human-in-the-loop AI. And really the premise here is we want to leverage AI for the things that it's good at doing. And we want to leverage humans for the things they're good at doing for now. And the reason is, I think most organizations are going to struggle with AI adoption if you think about it in the terms of how you would consider boiling the ocean. All of us have heard the hype, and we've all lived over the last 18 to 24 months or more about the hype around AI. But what I will tell you is, I think there is a structured process, which I hope to explain today, that allows you to use some of these out-of-the-box large language models to help you make decisions and to improve processes, business processes. We're doing a lot of different things with AI. So let me tell you a little bit about myself and Praxent and what we've been doing, and then we'll get into the meat of the process that I have here. So I work for a digital consulting company called Praxent. We're focused only in financial services. And since, I guess, around the beginning of this year, my primary focus has been applied AI. And we've been focusing on doing that in two, what I would say is distinct ways. One is product or process improvement. So how would we build AI into a product distinctly? You've all used products today that have AI in them, Notion, whatever else. And then on the other side, and processes as well that are involved in that. And then on the other side is what we're calling an agentic SDLC. I'm not talking about this today. It's fascinating. I have a lot to say on that. But we're using AI to eliminate some of the pain points in the software development lifecycle. And we're doing that in very targeted ways. And so my hope today, as we talk about this, we're going to talk about the different ways that organizations are going to adopt AI. And I did not coin these, got them off the internet. Sorry, I don't have the source. But most organizations are going to have about 4 stages of AI implementation. And it's really helpful to understand that, because as we think about applying AI, we think about it in the context that we hope that it will solve all of our problems for us. And we've all seen the M-dashes on social media and everything else that exists, and we know that it can't do that. So stage 1 is there are traditional processes without AI. This is where we all were a couple of years ago or something. Stage 2 is that we start to introduce human capabilities by providing suggestions and insights. So this might be a customer, I think this is the example here, a customer service team is using a chatbot to support inquiries that they're getting. So I've heard this a lot. You get a phone call, someone wants to better understand how to trade a certain stock or whatever, and you're working for Fidelity. You have a lot of tools, and you have a lot of SOPs and a lot of other things, and so you need something that will just assist from a knowledge-based perspective. Step 3 is that AI systems begin to handle routine tasks autonomously with a human overseeing outcomes. This is much closer to the story that I hope to tell today. It's somewhere it's like 3/4 to 3, we're at like 2.75. So this could be an AI product recommendation. It could be AI involved in underwriting strategies, other things. This is going to be an augmented form. And then, of course, step 4, this is full autonomy. This is end-to-end the thing that we all hope AI will eventually solve for us. Now, I want to pause for a second and talk really briefly about what I mean by AI, because as we think about AI, it means a lot from the past and it means a lot in the future, and we got to define our terms. So when I'm talking about applied AI today, I'm talking about the large language models, potentially smaller language models that we would all interact with on ChatGPT, Claude, et cetera. But there is a whole realm of machine learning and other things, and frankly, even those large language models are really evolved machine learning. So I just want to be clear, there are a lot of ways that you can use ML to make very clear decisions. The reason that those work, and we've been using them for decades, is because they're tuned with a bunch of data and things like that. It's not really good for business process people because they have to have a very tight box to be able to use those machine learning models well. And so when we think about next best product engines, which is closer to number 3 here, all of our financial institutions use that to promise us what loan or insurance product we're going to leverage. It's doing that based on a ton of data. Well, I don't want to spend 6 months developing a model, testing that model, paying some licensing fee or whatever else, or having to set up an entire data science team to solve a problem. What I would really like to be able to do is leverage a large language model to, using business language, solve a problem for me today. Now, that's easier said than done. So we have a decision bottleneck problem. In most of the organizations that we work for or know about, you have a lot of data coming in, and someone is going to make a decision. So the traditional way that you would get a loan, right? You would fill out, let's go way back, you'd fill out paperwork. It would literally go desk to desk, right? So if we have that in our mind, that process, by the way, whether or not you know it, has largely not changed in premise. In practice, it has, meaning if you go apply today for a mortgage, you're not going to necessarily mail in a physical piece of paperwork, but it is going to go desk to desk in a certain sense. There's at least a pipeline that is reflected on what that used to be. Credit, underwriting, other things that are going into that decisioning. And so this bottleneck is a real problem because to scale it out means that you have to throw people at the problem. And so the question that I was presented with is, how do we begin to solve that problem with AI? So can I issue more loans in the future, for instance, or can I process more claims in the future with the same amount of staff that I have today? And that's the question, because ultimately people are the problem. So let's talk about this sort of process thing that I'm calling double RAG that I would have renamed to human-in-the-loop AI. Really, it's 4 main things. So it's the data on the inbound. So that data may come in the form of documents, that may come in the form of feeds of data. That may be actually data that you already have about a user. Then you have to have a pipeline associated to being able to leverage that data well, and then for the AI really to be able to leverage that data. And we're going to talk about what that means. That's one of the RAGs. Out of the LLM, we're going to get enriched information. We're going to get some recommendations. We're going to get pattern matching. And then hopefully we can make a decision. Maybe we get an informed decision. Maybe we make a decision. So I want to tell a quick story before we keep going. So where I think there's a big difference in the type of tool that we're talking about here between a fully autonomous or a more fully autonomous tool and what I would say is human in the loop is pretty simple. So I had a company that recently talked to me about their product. And their product, they wanted to see if I would use a new feature. That new feature was going to scan my email inbox. And it was going to look for any email that it thought was relevant to that product, an invoice-related email. And then it was going to take that email and match it towards an invoice that is in another system, and it was going to apply a suggested response that I would give. Okay, so that's one option. The only non-automated part of about that is that it's not sending the email. The other option that they presented to me was a plugin that would sit alongside my email. And that plugin could be triggered at any given point. I could say, oh, this is an email that I want you to go and process. I want you to go and match, and I want you to draft for me a response. Now, instantly, that plugin makes way more sense to me for a lot of reasons around security, governance, and many other things, but also because of the fundamental problem that exists in front of both of those two choices in their product. The fundamental problem is what is a relevant email and what is not. And I will tell you today, AI is not great at that problem. It's okay at that problem, but you're going to fail if that is what you're trying to solve for. Now, it could look in all of my emails and it could decide, oh, someone specified invoice number. But the chance that a client is going to say to me, hey, invoice number 2137, I'm having trouble with it, what should I do? It's more likely the last invoice that you sent me. And then you're talking about fuzzy match stuff. But I could just say, hey, go and use your knowledge, generate for me a response to this invoice, and it would go and say, oh, I think this is the invoice that I want to use, and then it would draft that response for me. Now that's in premise the thing that we're talking about today. And that's why adding me as a human into that process is so vital. Because I can do that hard thing, which is understanding the pattern matching associated to what email is relevant, much better than trying to train an LLM to do it. Now, eventually I could get there. Don't get me wrong. There will be a product someday that will solve that problem. I believe that people can do it. But what I would say is the returns on the effort are like an exponential problem. I'm going to have to continue to iterate on the prompt associated towards getting that tool to understand that email in that context, okay? So sorry, I rambled a bit there. Any questions about that really quickly on why that's a challenge? Okay, so let's think about at a high level what I mean by this architecture, and we're gonna break out each part of this architecture as we go. Of course, documents and data, as I mentioned, are the beginning step. I'm going to pull that in, and I'm going to probably vectorize it. Although that may not be required, I could chunk it, and we'll talk about the few different ways. There's also another concept, if you haven't heard about it. It's using knowledge graphs now instead of just vector databases. So in the case of that customer call center, it might be better to use a knowledge graph than a vector database. But if you're analyzing a PDF that you've extracted data from or a subset of data, a vector database is very powerful. Knowledge graphs are great for large summaries of data, of course. So I need to search that vector database. I need to combine all of that. I need to throw it to the LLM with analysis. And I'm going to talk about structured ways to do input and output. And then ultimately, a decision has to be made, either recommended, depending on how I'm throwing the data at the LLM, or I, as a human, have to do that. So document ingestion is hard. Has anyone had to do much with taking either structured documents or unstructured documents and converting that to data for systems to use? Has anyone had to do much of that? Okay. So I mentioned at the beginning of the year, I started this journey of AI. I lied to you. I started the journey of complex OCR, because that is 75% of the problem that I'm dealing with today. And the reason is because for us to make decisions in financial services, I'll use a couple of examples. If you want to, well, let's just use the loan example as well, again, and I'll use a medical example. If I want to get a loan today, I need bank statements. So maybe I get Plaid, in which case I've opened banking data. I don't need to worry about some kind of thing here. But maybe I don't. Maybe my financial institution isn't connected. Am I going to do micro deposits and wait 3 days for that to happen? The answer is no, so I need to get you to upload bank statements. On the other side, if I'm doing a complex business loan, then I got tax documents I got to worry about. And by the way, I could write a paper on getting tax data out of a tax document. It is the most structured, unstructured document you could possibly have. As weird as that sounds, everything fits in the same place, but it doesn't. It's very complicated. And then in the medical industry, good luck getting doctor's notes out of things. And so you start talking about insurance claims, you start talking about pharmacy benefits. And then if you want to get into workers' comp and things like that, you start talking about multiple doctors, and they give you summaries. So you have to extract out a bunch of data that is very unstructured and maybe illegible, as most of our doctors have illegible handwriting. For some reason, that's a job requirement for them. So document ingestion, I think, is fundamental to this process because, and I mean, you could have a system that you don't have to worry about this with. That's fine. But I also think it lowers the barrier to entry for any AI tool to be able to leverage decision-making because it's so much faster. We're trying to, again, the whole process here is to reduce decision-making time. That means I need to get as close to the truth as quickly as I can, which means I'm probably getting documents. So let's talk about some options here. If you don't know, when you use ChatGPT today, it's a multimodal large language model, which means it has a concept of VLM built into it. A VLM can also exist in isolation. That's a vision language model. Basically, I could take this Chase fake, I think it's, let's see if a person's name on here, company name. It's from company name. I'm just kidding, it's just a dummy Chase thing, but I could take that and I could upload it to ChatGPT, and if I give it enough prompting and if the document itself is not terribly formatted, it can do a pretty good job of getting all the data out. I may, if I just ask it, give me all of the lines of deposits and additions every time, I may get that in a different format every time. I'm going to tell you about a way to solve that problem in a second. But it could do that. So like you could upload to ChatGPT today, what tree is this? If you take a picture of a tree and it does an okay job of maybe helping you pattern match. So vision language models, and there's a lot of people doing research into using LLMs to do that pattern matching because that's what they're good at doing for text. Now you can do standard OCR. So there's Tesseract, there's Mu PDF, My PDF. There's tons of different standard OCR. We've been doing that for years. And then there's hybrid. And this is where I think you really have the best of both worlds start to come to pass. So you could leverage your own out-of-the-box Python OCR tool and then throw that at an LLM. So the way that works is just really simply if the OCR can just get all the text out, and it does a pretty good job of getting it, especially with machine-generated documents, then the LLM can maybe help you pull out the specific data that you want. So imagine this, right? I take this document, it's machine-generated, I throw it at standard OCR, and then I throw all of that text just at an LLM, and I say, give me deposits and additions back. That's one way you could do it, and that's kind of a hybrid fashion, so that I don't have to tell the OCR tool, look for the deposits and additions header and give me everything below that. That's a very arduous process to program how an OCR tool could get just that table out. So that's a hybrid approach. Another one, AWS Text Tract. It's a really neat tool. If you haven't ever played with the AWS OCR tool, it's like some AWS services, it's all abstracted. They claim they do AI in the background. I think there's some machine learning built into it. If we have time, I can show you a little bit of an example that I did with that. But they give you back all of your data in a very structured fashion. You get these like groups of lines and blocks and things, and so you can sort of recreate a document in text form from the extracted text. It's also very good at recognizing text in various fashions. And then the new kid on the block, in my opinion, is a library called Dockling. Dockling has a small language model built into it, or it leverages one, and It's using both OCR and a small language model, very specifically tied to a VLM. And I'm blanking on the, you can go look it up. I'm blanking on the organization, but a large organization, I want to say it was like CVS, or something, came up with Dockling. Maybe it was IBM. IBM, okay. Sorry, there it is. And then in the world of document ingestion, we have some new players. So there's one that I found recently called Pulse. Pulse will kind of do that first hybrid thing that I mentioned on its own. Mistral just came out with an OCR model. And then AWS Nova is, by the way, AWS models as base foundation models, don't sleep on them. Nova is a really interesting model for applied use cases. One, it's super cheap. Two, it has some hidden features that I didn't even know about. So you can upload an entire PDF as bitstream directly to Nova, and it will interact with it. So you don't have to upload images. You just say, here's the doc, and then you can ask questions. And that's super neat because it takes out a huge step of the process. So as I said, like 75% of the things that I've been working on have been solving how we handle document ingestion and data. I want to hit a couple of quick points on retrieval-augmented generation, which is important. So that's still the first part of the RAG and the double RAG. So I'm sure most of you have heard about it or have performed RAG, or maybe you've built tools using like LangChain and other things, and it's just part of the process. But you really should understand what it's doing, especially if you're building a business process around it. RAG itself helps solve the problem that LLMs have around hallucination. Now, you can still hallucinate if you don't ask the right questions to an LLM using RAG, but it's much less likely. So it's grounded information for the LLMs. You should be able to update it easily. A fine-tuned model, you can't update, well, you can update it. It's just not easy. It's expensive and complicated. Using RAG, in this case, improves accuracy. And it's functioning as an extended pool of context, right? So we're going to start with the source data that we're getting, either from a document if it's long. So think like some of those doctor things that I told you about in the workers' comp example. We're talking about thousands of pages of decades of history associated to patients. We can't chunk that in a way that the LLM can leverage it. We can't just send that to the LLM. We have to put that into a vector database. So we're going to start with the source data. We're going to chunk and embed it. It's called embedding when you put it into a vector database. A knowledge graph handles that separately and differently. We're going to query it. So that process, so there's two main variables here. The chunking and embedding is a variable. So you can chunk data larger and smaller, and it will have a different impact on the response rate and the success rate that you get when you're using RAG in a RAG-based system. And then how you query the data and search and respond has a different response as well. That added text that comes back when you're querying the vector database will be used as context in the LLM. So if you looked at the history of what's going on, if you used LangChain or something like that, you would see a series of questions that come through in the LangChain, and then all of a sudden, all of the data that it found in the RAG response would go in, and then it would generate the output. And then lastly, you get the response. And so I have some links here if you're interested. AWS has a really cool article on what RAG is, IBM and Google as well. A lot of the tools that you're using today that have LLM-based sort of knowledge sources are using this methodology in the back end. It's cheap. So just as a comment on retrieval, this is off of Anthropic. They do it in a very interesting way, but there's multiple ways to do this. So it's a little hard to see, so I'm going to just describe it really quickly. You're going to have something searching your chunks, and then you're going to have something else that might re-rank the responses if you do it right. And then there's on both sides of the problem, and then in the middle you have a query. So as we know, when you Google something today, you get essentially the response back that you Googled, but it could be good, it could be bad. And so that's why one of the biggest knobs to turn as we're thinking about how we get the most out of these kind of RAG-enabled systems is how we adjust the query and the way that it's searching. So let's talk architecture of these systems a little bit. On the left, sorry, stage left, whatever, is a simple diagram of what most RAG systems will look like. You'll have some data that gets chunked, that gets embedded through an embedding model. It's put into a vector database. Then the retrieval context will happen when a question comes through or a prompt comes through. The LLM will generate a response. Sometimes those queries and prompts and responses can be fed back in, which can be helpful, especially if you're giving feedback on the response. On the right-hand side is Amazon Bedrock as a base, kind of how if you were to take Bedrock out of the box and use the tools that they have. So how many have heard about Amazon Bedrock? Who knows what it is? Okay, so if you don't know, just really briefly, they have a whole list of models that you can use there, like Claude. And of course, all of Amazon's models, a bunch of others. But they have also a whole agent suite that's built into it. What's cool about it, I think, is it gives us the ability to create agents very quickly that solve these kinds of problems. We can create a knowledge base straight out of S3. We can tie that into one of the models that exists and give it a simple prompt. And out of the box, we have some sort of chatbot that does a thing like this. And then we can also programmatically call that agent and do different things. We're doing this in systematic ways, built with MCP and other things that help solve problems with real customer data. So it's one thing to ask for a model based on a bunch of different inputs to generate like code or something for you. It's another thing to do it if you tell it to generate that code, but you have all of the documentation associated to how you want that code generated. So I would just say don't sleep on Bedrock because it could solve problems. I know enterprises that are 4, 5, 6, 10 times the size of our company doing it, and I know people much less as well. So the other really cool thing, by the way, about Bedrock, just as a side note, is you don't have to worry about all of the enterprise TOS-y stuff that you do in other places. And so when you're using it, you kind of just get the enterprise TOS. They're not training on your data. You get their ecosystem a lot better, so a lot easier. So let's talk about the other RAG then for a second. RAG in most contexts, especially business process, would stand for red, amber, green. And that's really what I meant behind the way that LLM today could help solve problems for us. So, of course, you have traffic lights that explain that. But then on the, the right-hand side, the other side, here is a credit box built into a spreadsheet. Now, right now, if I was an underwriter, I would have to go and do some pattern matching on a bunch of other tabs or have those tabs fill in. And then you can't really see it, but there's columns of information. And when that information gets entered, I have to decide whether or not that information is relevant. But if I could color code those through a simple response, through interpreted data, then immediately I have a Christmas tree on this page, right, that helps solve that problem. And so that's the kind of things that we're doing, or that I'm trying to solve for. So that's that kind of RAG. And so if we break this down for a credit decision, we have a dozen or more different data sources. We have a complex Excel decisioning template. We need to probably improve the data extraction process that we've been talking about for sure. And then we want to create, or we have created, simplified views for those thresholds to be called out. So you can set all the parameters that you want. You can pipe that data at an abstracted level so you're not worried about PII, right? Here is a credit score that I got back from FICO. Does that meet the standard? Now, that's also a really simple math thing, so we're not worried about that. But at the end of the day, we can run QC on some of these credit decisions. And maybe, I'll just make this up, maybe the credit score itself isn't a problem, but the credit score plus something else is. Now, an LLM would be able to help solve for that problem if you can encode that business logic into the query with the data. A human would be able to understand that as well, but you're asking a human to parse this really long list of data and make that decision. And what I'm saying is you could parse all of this data, you could pass it all into an LLM in a structured way and have it give you that response back. The way that looks also in this tool for us today is we want to call out those errors in line for underwriters and decision makers to make those decisions very easily. So when we find an issue in criminal history, it's doing text analysis. So just because someone has a criminal history doesn't necessarily mean that I need to call it out as a risk. So I have to pass that into an LLM. I have to say, is this, flag on their criminal history relevant? Bankruptcy is maybe the same case, and it depends. I mean, the bankruptcy is a little bit of a hard stop, but some of these others, so in this case, Jame here had both of those flags. In another example, so we talked about data at the beginning being a key source of the problem. Well, what if you have multiple sources of data that are solving or telling you the same thing? So in this case, we have multiple sources of data for the business name. And the borrower entered into the website, that's a whole other conversation, by the way, child care, not child care. And what we got back from the tax document or from Alloy or whatever was something different. And so we don't want to make that decision because what is right? I don't know. They could have fat-fingered their articles of incorporation or whatever else. I don't know what the right answer is. But I want to present all of that to this underwriter to say, yep, this is the one. So moving forward, I'm going based off of the 1040 or 1165 or whatever, right? So if I can bubble all of that up to the people that are making the decisions in clear ways, then I'm allowing those humans to do the decision-making that's hard. The LLM would know that's inconsistent, but it wouldn't know which one it needs to pick. Or the LLM would understand there are flags on Jame that I need to call out, but it wouldn't know if those are showstoppers, per se. So let's talk about structured input. I think it's pretty simple to explain in the context of data that's coming in not out of like a document. But prompt iteration is important when it comes to getting data back out from an LLM. So my opinion is most good prompts are going to take a half dozen to a dozen times to iterate through. So you're going to have maybe the LLM generate for you an initial prompt. So how do I use this data to get the answer that I want? But I need to keep working on it. Prompt iteration is kind of like design in the context of data engineering. If I'm designing a software system like this example here, I can iterate very quickly on this design if I was a designer. Changing code is not easy, but changing a prompt is relatively simple. So I need to be able to take that structured data out of whatever system. So this is actually a Textract implementation. I'm going through all the pages and getting all the different block and text information here and combining that all into a fashion that I can then send to the LLM. Really quickly, let's make sure I'm going to pick up the right one here. If I wanted to give a really structured prompt, in this case I'm using, as I mentioned, Nova, and I'm trying to get 1040 information out of it, I'm going to leverage an LLM to help me generate something like this prompt on the right-hand side. And I'm going to tell it to do things like, hey, here's what I want you to target, here's what I want you to fall back on. This prompt itself, I think is at prompt number, like version number like 6 or something like that, So as I get the responses back, as an engineer and as someone who's programming this in-the-loop process, I'm adjusting. So this is one way to allow for context-appropriate things. In the case of the actual agent that I wrote, it's taking the prompt and it's injecting all of the data alongside of it. So I have to handle that in code. But one of the things I wanted to show is just I don't know if anyone has seen kind of these, what I would call programmatic ways to handle prompts in LangChain and other things, but they can get very long, they get very complex. And then, let's see, that's not a good example. Just as a quick example, when I'm calling Textract to run a process and then I'm putting it through the LLM, I'm leveraging Textract to process all the responses, and then I'm dumping all of that data basically into the LLM on an iteration. Sorry, I was in the wrong spot. Anyway, let's get back. So the structured input, the way that we're going to classify and tell the LLM what kind of data we're giving it is very important. Requires iteration. It's going to take some prompt analysis for that. Then really quickly, hitting a couple last subjects, I think the most important thing that you can do is handling structured output. So if you don't know it, if you're leveraging something like LangChain or whatever else, a lot of the models now offer built in, so OpenAI has this feature around structured output. You can tell it to give you structured output. LangChain has a way of doing that as well. I have a link in the bottom right-hand corner here, and this is actually from their website. The idea is we want to give it a certain schema. So I have an example here of a Zod schema that we use in one context to get a very clear and structured output from the LLM. So when I'm getting a response on this annotation schema, it's coming back as an object. And that is what gives the ability for me to use that LLM response in other applications in a very fast and sort of friendly way. If I asked the LLM every time to explain to me who Lance is and why he has a bike, I may get that response back in any number of fashions. So as we're thinking about replacing humans with AI features, we have to have that ability to take that unstructured data, structure it, give it to a way that the LLM understands it, and then get back a very structured response so that we can handle that response, plug it into the spreadsheet, do whatever we want. So I want to share we already talked about the stuff on the left side, so we're not going to get into it, but the big other lesson that I learned is that trust is so important to these processes. So right now, as we mentioned earlier, a underwriter has those documents at their desk, so to speak. They're used to that. How do they know that the LLM or any other AI tool that you're using is giving them a good decision? And the answer is you have to surface that information to them. So I'm not going to just make a decision and show it to them. Like in that other example, I showed them all the other different examples of data that I got back from the system to allow them to do the pattern matching. I also want it to be able to explain why, through annotation, through other methodologies, why it made a certain decision, highlighting the screenshot, highlighting the source data. You shouldn't trust it at face value. So surfacing that source data. And then I have to essentially sell the team on why this is important. So humans do need buy-in. They need to validate. Human validation is important because I can feed that validation back into the process. It creates a feedback loop. And humans feel better when they see the process improve. There are things to consider when it comes to safeguards around this process. I would tell you, as I just mentioned, source attribution, link how it came to the information, screenshot it, do something. Trail, you need to audit trail, you need to log how it's coming to those decisions. What data did I get in? What data did I get out? Where did I show that to the user? consider performance monitoring. There are tools that exist. This one was actually made by CVS. It's called UQLM. And it allows you, if you implemented that framework, it allows you to have a sort of a scoring scheme for decisions that are made in a binary fashion. And it's doing that based on the way that an LLM works. An LLM is a next word generator in a sense, right? We all know that. And if you give it, in fact, they describe it really well on their website, but if you give it a question, who was the first president of the United States, the LLM could maybe generate 3 or 4 responses. One might be the first, I think I said first president. The first president was George Washington. The first president was George Bush. And if you use UQLM, it would actually tell you that the likelihood of George Bush was very low. Not an impossibility, but just very low. And that's fascinating because you're putting actual data and metrics behind. So it's like a safeguard thing. And there's a couple of others that are out there. Encourage you to find tools like that. And so kind of as I wrap up here, I'd just encourage you to get started. And really, the place that you get started is identifying workflows. Where are humans taking a lot of time to solve a problem? Where do you think you could apply an LLM to it? Prototype it out, validate it, get buy-in around it, measure the success that you're getting, and then iterate on it, because like those prompts, like so many other things, we need to evolve the tools and systems that we create. So you can find me on LinkedIn. You can find information about Praxent. And I'd love to answer any questions or hear if anyone else has had any success around using LLMs to solve business processes, human-in-the-loop stuff like that. Any questions? Comments?
Forgive me, to make sure I've understood. So is double RAG LLM in terms of, you've obviously got the initial RAG implementation, you're then using that to create another set of data that you're then making a decision on? That's double
It's red, amber, green. So is this a good decision? So I showed you that example of like risk. Where was it? Shoot. Not there. Here. So it's not a full no. You should go look at this underwriter. Right. Well, and I think the other, this one says it's not actually green. It should have been green. But it says no risk, right? We didn't find any problems here. So you probably don't need to go look at lawsuits or sanctions or corporate filings. You could if you want to. And we'll show you that stuff later. But we really think you should look here. And if I wanted to set a threshold for red, it might be any form of bankruptcy is an immediate no. That's fine. That's just a hard decision. So that's the concept of RAG. Second RAG. I forced myself with the talk title into that. Anyway, any other questions? Has anyone seen this work in their environments well? Have you tried to do anything like this before? Well, cool. If you have any other questions or are interested in exploring some use cases, happy to talk about that and give my thoughts on ways that we've done similar things or thinking about it. It's one thing to have an idea, it's another thing to have an opportunity to do it. So I've probably thought about a dozen other ways that we can do things like this. And I appreciate you coming. So thank you.